Good afternoon, everyone. My name is Reza Karimi. I'm with Huawei Technologies, and it's my pleasure to be here to talk to you about GSA's views on spectrum sharing. So, without further ado, let's move on to a foreword for this talk. This presentation provides the views of the GSA on the co-channel sharing of spectrum from the perspective of mobile communication networks based on IMT technologies as specified by 3GPP. And these include 4G and 5G NR, referred to as IMT networks in this presentation. Our emphasis here is on co-channel spectrum sharing. Adjacent channel sharing is, of course, also important, but management of adjacent channel interference is the bread and butter of spectrum regulations. So we focus on the more challenging item, which is co-channel spectrum sharing. Secondly, we note that the issues of inter-service and intra-service spectrum sharing often get conflated and resulting in misunderstandings. For this reason, we treat these separately in what follows. So we look at spectrum sharing in the context of inter-service and intra-service sharing. So let's look at inter-service sharing first. So by way of introduction, inter-service sharing refers to co-channel sharing of spectrum between IMT networks and existing users of other services in a given band. By other services, we mean, for example, the fixed satellite service or the fixed service or radio astronomy, to name a few. In other words, other services in the context of the ITUR. We note that there is growing demand for terrestrial mobile broadband connectivity, and we also note that frequency replanning or clearance of incumbents may not be possible in all cases. This means that increasing levels of spectrum sharing between IMT networks and other services may be inevitable going forward, and we've seen examples of this already. As such, the mobile industry has been very active in recent years in establishing efficient inter-service spectrum sharing frameworks at a global level in order to allow more extensive use of the scarce spectrum resource. And the prime example of this is the 26 gigahertz band where IMT networks coexist with satellite services. So here are some of our recommendations in the context of inter-service spectrum sharing. So the GSA considers that where possible, bands considered for use by IMT networks should be cleared of existing users of spectrum, particularly in geographical areas where IMT networks are to be deployed. And this is in order to avoid uncertainties within the interference environment and to deliver the challenging IMT 2020 quality of service requirements specified by the ITUR. And then recommendation B says that where cost benefit or other analysis indicates that clearance of existing users might not be a viable option, sharing of spectrum between IMT networks and existing users of the band could and should be considered, always subject to least restrictive technical conditions. And by least restrictive technical conditions, we mean the imposition of minimal regulatory technical requirements to result in acceptably low probability of harmful interference. To achieve this, it's important that we use realistic assumptions in our modeling of interference and avoid worst case upon worst case assumptions. We're pleased that many regulators worldwide, including Ofcom in the UK, are explicitly emphasizing the importance of realistic modeling, including enhanced radio propagation models in coexistence studies. So some other recommendations. Item C says that where sharing of spectrum between IMT networks and existing users is the only option available, careful consideration should be given to the sharing objectives and requirements and their impact on the operation of all parties, and should not deter the substantial long-term investments needed for the rollout of IMT networks. And this basically says that spectrum sharing has economic implications, which should also be taken account of. Item D says that in order to minimize costs and complexity, spectrum sharing between IMT networks and existing users should be preferably considered first in bands where the geographic locations of existing incumbent users are known, are not ubiquitous, and do not vary with time in relation to the IMT networks. And I hope this last item makes sense to everyone. It's evident that sharing can be most readily achievable when the existing user's radio receivers are at known and fixed locations, and that they are not located everywhere. If these conditions are not met, then sharing can become increasingly costly and complex. For example, if the existing user's receivers are everywhere, then the sharing technical conditions for IMT would most likely be over-restrictive. Or if the existing user's receivers are not fixed and can suddenly appear or disappear, then again, this can have negative implications on the delivery of IMT quality of service as specified by ITUR, both for mobile broadband and vertical use cases. And our final recommendation on inter-service sharing is that where appropriate, various coordination approaches may be applied to facilitate spectrum sharing between IMT networks and existing users. Again, this is related to our preference for first considering sharing in bands where the existing users are fixed and not located everywhere, which means that coordination can be then much simpler to achieve. So that's all we had for inter-service sharing. Now let's turn our attention to intra-service sharing. So again, by way of introduction, intra-service sharing refers to co-channel sharing of spectrum between different IMT networks, public or private, in a given band. We note that IMT networks are themselves highly sophisticated spectrum sharing systems, and that through technologies such as cellular frequency reuse and network slicing, IMT networks allow billions of users and devices to share the same frequencies in the pursuit of a wide variety of use cases and with a predictable managed quality of service. And I think this last point is quite pertinent in the sense that nowadays there's a lot of talk about dynamic spectrum access and database assisted access to spectrum. I think we shouldn't forget that mobile networks are essentially themselves extremely sophisticated spectrum sharing databases. Furthermore, in the context of authorization models for IMT networks, we note that individual licensing in all its various flavors, and by various flavors, we mean whether they are nationwide licensing or regional licensing or local licensing. These are all essential for the delivery of a predictable quality of service by allowing IMT networks to control the number of spectrum users and to efficiently distribute the radio resource among them in a deterministic manner. And it's precisely for this reason that IMT technologies are designed to operate subject to individual licensing in order to deliver the challenging technical requirements set out by the ITUR. And I think this last point is again worth elaborating on. Some folks talk about co-channel spectrum sharing between Wi-Fi and IMT 5GNR at the same time and at the same location. And this really doesn't make sense. Wi-Fi's medium access control protocol is designed to operate in the stochastic interference environment of license-exempt spectrum. The protocols of Wi-Fi basically allow distributed contention between independent Wi-Fi radios, and Wi-Fi would be very spectrally inefficient and it would be wasted in licensed spectrum. On the other hand, IMT 5GNR is designed to operate in the more deterministic environment of licensed spectrum. It would fail badly in the interference environment of license-exempt spectrum. So talking about co-channel sharing between Wi-Fi and 5GNR doesn't really make sense. It would mean taking a technology that's optimized for one type of interference environment and asking it to operate in something completely different. And I would urge everyone to think very carefully about these fundamental radio engineering issues before thinking about co-channel spectrum sharing of Wi-Fi and IMT at the same time and at the same location. So let's look at some of our recommendations in the context of intra-service spectrum sharing. So GSA considers that individual wide area / national licensing is the preferred authorization regime for IMT networks for the delivery of services with a predictable and managed quality of service, including for enhanced mobile broadband, ultra-reliable low-latency communications, and massive machine-type communications. And any desired sharing of spectrum among wide area national IMT network licensees should ideally be market-led and can already be implemented through multi-operator core network technologies specified in 3GPP. And these technologies allow mobile operators to pool their spectrum resources, resulting in improved trunking efficiencies, should they wish to do so. Some other recommendations. GSA considers that where there is a justified demand from parties to deploy private IMT networks within limited geographical areas, market-led intra-service spectrum sharing should be preferably achieved through leasing of spectrum from the individual wide area / national IMT network licensees. So for us, leasing is an option which should be considered in the first instance, as it avoids spectrum fragmentation in the form of set-asides for different uses of IMT networks. So item I is also related to item H, but is a different angle. And it says where there's a justified demand from parties to deploy private IMT networks within limited geographic areas, intra-service spectrum sharing could also be achieved through local licensing of frequencies, which are not co-channel with those used by wide area / national IMT networks. Any local licenses should be available to all interested parties and should not in any way compromise the availability of nationwide licensed spectrum with large contiguous blocks for wide area / national IMT networks. And this is important. Local licenses should not be co-channel with wide area licenses, because we're talking here about uses that can be in quite close proximity. For example, a national public network and private networks. And managing co-channel interference in these circumstances is not a trivial matter. So let's keep the local licenses and the national licenses at different frequencies. Other recommendations, predictable access to spectrum, uninflated and predictable costs of spectrum, and a stable interference environment, both co-channel and adjacent channel, are all essential to exploit the reliability, low latency, and spectrum efficiency of IMT networks, and to incentivize investments in capacity and coverage. This is key both for public and private networks. And I'd like to emphasize these two points: predictable access and stable interference environment. And again, this applies to both public networks and private networks in terms of delivering quality of service. And in this sense, frameworks which use dynamic and opportunistic access to spectrum are not really helpful, because it's no good for example, a smart factory which has access to some, say, locally licensed spectrum, suddenly have to lose some of that spectrum because someone else suddenly acquires a license to use that same spectrum. And unfortunately, this is exactly the type of dynamic opportunistic access which some folks are promoting, and it doesn't really make sense in terms of incentivizing investments. So compared to such dynamic opportunistic mechanisms, I think the leasing from MNOs or the kind of first come first served shared access licensing adopted by Ofcom in the UK might be preferred. So item K says that where certain parties are contented with deploying communication networks with dynamic / opportunistic access to spectrum, the use of bands that are subject to general authorization, in other words, license exemption, are recommended for this purpose. Such opportunistic access is, for example, offered by 5G NRU, which is being developed in 3GPP to be used in license exempt spectrum. So in short, if your use case is such that opportunistic or dynamic spectrum access is something that's okay, then licensed spectrum is not really optimum for you. It's much better for the user to use unlicensed or, in other words, license exempt spectrum. So the last two recommendations say that in case of dynamic spectrum access, adjacent channel interference should also be addressed by the regulators. And finally, that IMT network deployments take place over time and are based on evolving traffic demands and uptake of use cases. Therefore, spectrum in specific geographic, remote or rural areas may not be used by MNOs in these early days of network deployment. MNO strategies and long-term plans should be considered before concluding on the efficiency of MNO spectrum use. So with that, allow me to summarize our position and recommendations. Broadly speaking, spectrum sharing should only be considered where there is a clear demand for additional spectrum, which otherwise cannot be made available, and where the benefits outweigh the costs. In other words, spectrum sharing and complex proposals for intra-service spectrum sharing in particular should not be considered as goals in themselves, but must bring tangible net benefits to users of spectrum. And finally, the GSA considers that existing spectrum authorization frameworks based on individual licensing and license exemption in distinct frequencies respectively that's available today are sufficient to cater for all foreseen intra-service spectrum sharing scenarios for innovative use cases. Where there might be demand for dynamic/opportunistic intra-service spectrum sharing, these can already be catered for using license exempt bands. Therefore, GSA does not see a need for additional spectrum sharing frameworks to cater for such dynamic/opportunistic uses of spectrum. And this brings me to the end of my presentation, and I thank you very much for your attention.